All right, so in this particular case, we are going to look at problem number 3 for RC circuits here, and we are going to use the following equation. So it's the same equation that was given to us, and that's way down here. It's this equation right here. And so basically, we're just going to multiply R on both sides. And we know from Ohm's law, I guess I should use something a little bit different. We know for Ohm's law that I times R is just V. So we have our voltage here, okay? And the EMF is, which is right here, is given to us in the problem. So in my particular case, it is 200 volts. Yours, it might be something different. My time here is not a vector. All right, so this is my time. And that's the time after throwing the switch. We have our capacitance here as well as our resistance. So again, I'm a big fan of Excel when it comes to doing these calculations. It's just like algebra on steroids. So let's get to it. Here we go. So I am just going to create a new sheet here. And I do like some of the titles that I have right here. Time constant, charge. Do I need charge on a capacitor to give? No, not that one. So I'm just going to take this. I'm just going to say copy, and then I'm going to paste this. All right. So we know what we're talking about. Even though it's algebra or mathematics, we have some nice concepts here. It's really good, really not good, but it's really useful. So let's go ahead and place our resistance in here. And the best way that I'm going to do this is not from memory. Okay, so my resistance is 47,020. Let me pronounce it right. The capacitance of the capacitor is going to be, we see it here, 4925, and that's a microfarad. So that's going to be E negative 6. All right. And then we have the charging time. So that time was given to me in the problem as it will be given to you. You're just going to have different numbers, 0.71015. I think that's correct. And then the EMF that was given was 200. So these are all of our given values. I mean, we literally could color that in green if we wanted to. The first thing that I want to do is I want to calculate the time constant because we will use that if you remember. So the time constant is in this voltage equation. It's the tau. Ooh, do I have, I better quit misbehaving. All right, so it's just going to be R times C. So it's my resistance times, why did you get small, times my capacitance. So I have my time here. It's in scientific notation, but just know that it's, what, 232 seconds, all right? It may not be that useful, but we're pursuing our calculation. So now that we have everything, we're just going to go ahead and find the voltage across the capacitor at this given time. So I do want to write that in here. It may seem like a lot to write all of this stuff in here, but I don't want to think about it when I look back at this calculator, wondering what work I've done. I mean, it's almost like a loss of work. So you have to do it again at a given time. And we know what our given time is. And also, I'm just going to go ahead and put my units in. Always very important. No need to think about it once you have it. All right, I'm going to wrap that text. So I want my voltage alignment. Let me go ahead and wrap. Get rid of that. I'm just going to wrap my text. And I'll go ahead and middle as well as center it. And this is just for readability. So my voltage across the capacitor, let me go ahead and bring my documentation back up here. All right, there it is. So all we have to do, this cell is our voltage. This is the beautiful thing about it. It's algebra. This cell is voltage. So now we have a time. We literally could tie this to the time cell, which is what we're going to do, equals to our EMF times the power, okay, of the exponent. And this is not Q, but 1. And we need to raise that exponent to a given power, and that power is going to be, and did I calculate the time? Oh, yeah, the time is here. I didn't have to. It's a negative time divided by the time constant. And I think that's it. All right. So this is our voltage across the capacitor at the given time. Okay, or at a given time in our case. The next thing that we want to do is we want to calculate the current going through the resistor. So the current going through so notice that the current and the resistor, they're in series in this particular case. So the current, if I could spell, current flowing through the resistor. Okay, so I'm just going to say OHM. I did. Okay. So again, I don't want to leave this in this form. I'm going to go ahead and wrap my text, and I will also behave by middling and centering it so that it is readable by all. All right, so the current flowing through the resistor. So we know the voltage, okay? And we know the resistance. So that should give us our current, okay? So the voltage across the capacitor at a given time, over the resistance. I really would not expect this. Okay, so the voltage divided by the resistance here. Okay, and of course, we can reduce the amount of decimal places here, and I'm just going to increase it to a couple, and we can reduce the amount here. I can just change this to a number, then increase the decimal places as I see fit. All right, so I think that is all you need for this particular problem, and hopefully this helps.